to see the principle of parallel axis. Principle of parallel axis and principle of perpendicular axis. First we will see principle of parallel axis. Here we consider first the statement of principle of parallel axis. The moment of inertia of a body about any axis is equal to the sum of its moment of inertia about a parallel axis passing through its CM and the product of mass of the body and square of the distance between the two axes. This is our statement. See here, suppose we consider this is a body of any shape, and suppose we have to consider here, suppose here this is the body, and we consider suppose this is the center of mass of the body and this is any point. Suppose we consider O be the any point. Now suppose we have to obtain the moment of inertia of a body about an axis passing through point O. That means body rotates, we consider here body rotates about this axis as an axis of rotation. See here. Now suppose IO be the moment of inertia body about this axis. Now we consider suppose another axis which is parallel to this axis. See here, these two axes are parallel. See here, not like this, parallel and passing through also center of mass. These two axes are parallel, not like this, not like this. All these axes are passing through C, but they are not parallel. Only this axis is parallel. These two axes are parallel. See here. Now suppose IO be the moment of inertia body about this axis, IC be the moment of inertia body about this axis which passes through the center of mass, and suppose this distance we consider here, this distance is R, the distance between the two. Then here we consider IO is equal to IC plus MR square. This is our statement. That is, moment of inertia of a body about any axis means IO is equal to sum of plus sign, sum of moment of inertia of a body about a parallel axis, these two axes are parallel, passing through center of mass, and product of mass of a body and square of the distance between the two axes. This is the statement. Now suppose we have to prove this. We consider proof. Suppose we consider a body of any shape. Now suppose we consider here this point is C, this point is O. Now axis of rotation passes through point O like this. See here. And suppose body rotates about this axis, IO be the moment of inertia. Axis of rotation passes through point C and body rotates about this axis, IC be the moment of inertia. Distance between these two is R and capital M is mass of the body. Then our statement is IO is equal to IC, IO is equal to IC plus MR square. This is our statement. Now to prove this, suppose we consider any point P of this body and small mass dm is placed at this point P. Now we do some geometrical constructions. Suppose I join OP, suppose I join CP, suppose we extend OC and we draw perpendicular from P. Suppose this perpendicular is D. That is, we get these triangles OPD and CPD. Now here we consider the moment of inertia of small element dm about an axis passing through point O is, we can write here, that is OP square dm. Moment of inertia of small mass dm about an axis passing through point O is OP square dm is mass into distance square, and the total moment of inertia of the body about this axis is obtained by integrating this, and we consider this as IO. Suppose this is equation number 1. Now, moment of inertia of small mass dm about an axis passing through point C is, I can write here, that is Cp square dm, distance square into mass, mass into distance square, and total moment of inertia of this body is obtained by integrating this. So integration is equal to, we can write here, Ic, and suppose this is equation number 2. Now, from figure, we can write here, that is OP square is equal to, see here, OPD, triangle OPD, we use Pythagoras directly. OP square is equal to, we can write here, OD square plus PD square. This is by using Pythagoras. Now we split this OD like that. OC plus CD square plus PD square. OC square, we expand this, OC square plus twice OC CD plus CD square plus PD square, and this CD square plus PD square, if you consider this triangle CPD, then CD square plus PD square is equal to CP square. Therefore I will write here OC square plus twice OCCD plus CP square. Suppose this is OP square, and this is equation number 3. We put this equation 3 in equation 1, then we get here IO is equal to integration. Value of OP is OC square plus twice OCCD plus CP square into dm. Now we split this integration. OC square dm plus integration twice OCCD dm plus integration CP square dm, which is equal to, now OC we take outside, OC square integration of dm plus twice OC integration of CD dm plus here CP square dm as it is. Now OC means R square, and integration of dm means total mass m plus twice OC, we write this integration as 0 plus IC. See here IO is equal to, here twice OC into 0 because integration of CD dm is always 0 because x coordinate of center of mass is always 0 since, okay, and therefore we can write here IO is equal to IC plus MR square. IO is equal to IC plus MR square. Suppose this is equation number 4, this is equation number 5, and this is our statement of the principle of parallel axis. I hope you all understand this. Now we will consider next principle of perpendicular axis. Here, suppose we consider first statement. Suppose we consider a body is a plane lamina. Suppose you consider only this plane lamina. Now, suppose we consider, suppose this is the x-axis, and suppose body rotates about this axis like this. See here, x-axis as a axis of rotation, and suppose Ix be the moment of inertia. Now we consider same thing. Suppose this is the y-axis, and suppose body rotates about this y-axis as a axis of rotation. Iy be the moment of inertia, and now we consider third axis. Suppose this is z-axis as a axis of rotation, and suppose body rotates like this. The z-axis is perpendicular to the plane of lamina of the body. Then, according to principle of perpendicular axis, I will write here Iz is equal to Ix plus Iy. This is our statement. Here means moment of inertia of a body about an axis perpendicular to the plane of lamina is sum of moment of inertia of a body about two perpendicular axes x and y which are in the plane of lamina of the body and perpendicular to third axis. This is our statement. Now we have to prove this. Suppose we consider we have to prove this. Suppose you consider body of any shape, and suppose this O be the point. Suppose this is x-axis as a x of rotation, this is y-axis as a x of rotation, and we consider third axis z-axis as a x of rotation. When your body rotates about this axis, suppose Ix be the moment of inertia, this is proof. When body rotates about y-axis, Iy be the moment of inertia, and when body rotates about z-axis, Iz be the moment of inertia. Now, to prove the principle, we consider suppose any point P, and at this point P, suppose small mass dm is placed. Suppose you consider x, y, z. These are the coordinates of this point P. See here, x coordinate means distance of point P from y-axis. This is x coordinate. Y coordinate means distance of point P from x-axis, and z coordinate means here we consider distance of point P from z-axis, like this. Now we consider here, suppose small mass dm is placed at point P, then moment of inertia of this small mass dm at point P about x-axis, I will write here, about x-axis is equal to, I will write here, that is y square dm, because y square distance square into mass, and if we integrate this, then we get here total moment of inertia, that is Ix. Suppose this is equation number 1. Similarly, moment of inertia of a small mass dm about y-axis is, I can write here, that is x square dm, and if we integrate this, then we get here Iy, total moment of inertia of a body as y-axis as x of rotation. Suppose this equation number 2. Now here suppose I directly add these equations 1 and equation 2, I get here Ix plus Iy is equal to integration of y square dm plus integration of x square dm, which is equal to, here I will write x square plus y square into dm, and if we use the Pythagoras directly, x square plus, here this is x square plus y square means we can consider here, because here this is right angle triangle, and I can write here z square dm, and therefore I write here Iz, this is the moment of inertia of a body when z axis is x of rotation, and therefore Ix plus Iy is equal to Iz. Suppose this is equation number 3, and in this way we have proved the principle of perpendicular axis. I hope you all understand this. Thank you.